Peace be with you, geometry students. I trust you're keeping the thought of the Lord Jesus close to you, and He will help you, He will protect you, preserve you, and I'm sure keep you in peace, even in the midst of the worst storm. I want to encourage you to read the last story in Mark chapter 4, towards the end of the chapter, and you'll see the kind of help we have, even when storms are raging. All right, so I'm going to trust that you'll guide us, Lord, and you will protect and preserve us. This will be a practice test for you whenever we come back. We come back Monday, you might be having it the Tuesday, but you will have it the second day after we come back, not that very day. I was thinking of giving it Monday if we get back on Monday, but I'd like to take a little bit more time and review with you before actually doing the test, so you can take a look at this, and I'm sure it will help you not only while we're off for these few days, but in anticipation for the upcoming test. It will be, I'm sure, by the latest Wednesday for everyone. And this is geometry, and it will be good for not only the regular geometry students, but also the standard geometry students. Okay, so let's go ahead and begin. I want to begin with something which I've not taught you before, but I'm going to teach it to you now. So pay close attention as we look at numbers 11 through 13. It says, use the diagram to answer each of the following. Write may be assumed or may not be assumed. And this is fairly straightforward, but we just haven't gone over it together yet. Let's see what this first statement is. The statement says that line R is parallel to line S. Here's line R, parallel to line S. And you say, well, how can I know if we may assume that? And some of you probably already know the answer, that because we've got an arrow here and a matching arrow here, these two matching arrows indicate that these two lines are parallel. Whenever you have matching arrows like this, these two, that means this line is parallel to this. Or if you had two arrows like this, let's say you had two arrows, two here and two matching arrows here, it would mean that these two lines are parallel. Or you could have three or four, as long as they're matching. Okay, let's just keep it one for now. So you're right here, may be assumed. Again, that is because of the matching arrows on those lines. How about number 12? You know what this upside down T means? I'm sure you do. Line R is perpendicular to line T. Line R, perpendicular to line T. Now, some of you might be saying, yes, they seem to be perpendicular. This seems to be a right angle here. And some may be saying, well, I'm not sure. Well, the real answer is it may not be assumed. If we had a box here, then that would mean these two lines are perpendicular. But not having a box here, which specifically tells you that they are at right angles, you don't know. Because they might seem to be, but it could be 91 degrees. This could be 91. And it's pretty close to a right angle. Or it could be 89 degrees. All right? But once you have the box there, then you know for sure they're perpendicular. So let's take those out. No box there means may not be assumed. May not. Should be an N. Be assumed. How about this one? Angle 1 congruent to angle 2. Angle 1 congruent to angle 2. What do you think? May we assume those two angles are congruent? Yes, we may. Once you've got an arc here and a matching arc over here, those two arcs indicate that the angles are the same. This could be 39. Yeah, it's 39 here and 39 here. So this may be assumed. If there were no matching arcs, then you may not assume it. Unless you're given, where you have a statement that says, given that angle 1 is congruent to angle 2. Alright? Now, how about these here? It says, find x in each of the following. You look at this, you got a line here. And this angle here is given as 2x. And this bigger angle seems to be obtuse, so I'm going to put a double arc here because they're not given to be equal or congruent to each other. So I'm not going to put the same single arc here and here. What I do know is that whenever I have a line, straight angle is 180 degrees. So 2x plus 3x is 180. That's a setup to find x. I'd like you to show your work, set up your work, so it can be seen clearly what you're doing. 2x plus 3x is 5x. Equals 180. And to find x, what should we do? I'm sure you know. And this here you say, let's divide by 5. That's exactly what we do. Divide both sides by 5. And when we do, we have 180 divided by 5. 5 cannot go into 1, but 5 will go into 18. 5 times 3 is 15. That's the closest we can come. When we subtract 8, take away 5 is 3. Compare, 3 is less than 5. We bring down to 0. 5 goes into 36 times. 5 times 6 is 30. The answer here is x equals 36. Alright, what I'd like to encourage you to do is just to rework these, just for practice, because your test will look very similar to this. Of course, the numbers will be different, but the test will look very similar. Okay, here we got two lines intersecting. We have an angle over here and an angle over here. Notice I'm giving the same single arc because these two angles, they bear a special relationship to each other. What is that? I can just hear some of you saying, the vertical angles, they are. Vertical angles are always equal to each other or congruent to each other. So 9x minus 72 is equal to 5x minus 8. And this is the algebra. Whenever you have the algebra like this, x on the left, x on the right, the objective, the main thing you want to do is to put the variables on one side, especially on the left, and the numbers on the right. So to get the numbers away from the left side, we add 72 because this is a subtract here. So we do the opposite. When we do, since these are different signs, we subtract 8 from 72. It's 64 and we use the sign of the larger one. So it is positive. You might say, are you positive? Yes, I'm positive. And over here we have 9x equals, and now we're going to move the variables to the left. So we want to move away the 5x from the right side of the equal sign, and we do that. Subtract because this is understood to be positive. This was gone. This is gone. 9x take away 5x is 4x equals 64. Now we divide both sides by 4. (64) divided by 4. 4 goes into 6 once. 1 times 4 is 4. Subtract. 6 take away 4 is 2. Bring down. 4 goes into 24 6 times. 6 times 4 is 24. So for this one, x is equal to 16. And I know some of you got it from in class, but it's good to just rework it. Even just cover your work or just go to a blank sheet of paper and rework it just to get the practice. Now, what do we have here? Identify each of the classification of the angle pairs specified. One pair of alternate interior angles. This is the interior. In here between the two lines, this is the transversal. So alternate interior would be this one and this one, because they're on alternate sides of the transversal at the interior. So this would be angle 3 and angle 8. And another pair of alternate interior angles would be angle 4 and angle 5. How about a pair of same side or consecutive interior angles? Same side means the same side of the transversal. So it would be angle 3 and angle 5. They're at the interior. Angle 3 and angle 5. And finally here, one pair of corresponding angles. Corresponding means matching. So I could take, let's say, this angle 1, which is at the top left of this juncture, matches with angle 8, which is top left of this juncture. So we have angle 1 and angle 8. Another pair would be angle 3, bottom right, and angle 6, bottom right. All right? Now let's go to one which we did not touch in class for some. And that is this one right here. This might be the last one we were able to do. So pay close attention as we do this one. Given lines A and B intersect as shown. This is line A. This is line B. We're required to prove that angle 1 and angle 3 are congruent, and you know these are vertical angles. So we're actually proving the vertical angle theorem here. So let's go ahead and do it. Lines, first statement, lines A and B intersect. That's what we're given. So where's that given? It's given right here. The next thing will not be given though. As you look at this, you can see that these two angles, angle 1 and angle 2, they add up to 180. Measure of angle 1 plus measure of angle 2 equals 180. So why is that so? This is definition of linear pair. They're a linear pair of angles, or they're supplementary. Always supplementary. In addition, if you look at this line B, you'll see a similar thing. Angle 2 and angle 3 add up to 180. So we have measure of angle 2 plus measure of angle 3 equals 180. It's for the same reason, definition of linear pair or supplementary. Now listen carefully. Measure of angle 1 plus measure of angle 2 is 180. And 180 is the same as measure of angle 2 plus measure of angle 3. So we can say that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. The reason for that is transitive property. And finally, we can subtract measure of angle 2 from both sides, from this side and this side. So we get measure of angle 1 equals measure of angle 3. This is subtraction property. And then we can go from equality to congruence like this. Angle 1 congruent to angle 3. And this is definition of congruence.